Okay, this is ABC 197. Excuse me. Alright, let's see. That's problem A. Problem B. Okay. Squares visible if they're in the same row or column. There's no obstacle between them. Okay. Okay. That's B. Okay. N is small enough to where we can just check all possible arrangements. problem D. Let's see. Okay. So N. Okay. We just have to find the midpoint and then like rotate that point around by the midpoint. Yeah. Okay. Okay. So if our point was here, midpoint. We want to center around the midpoint. So we should do this. And then we rotate it, right? Is it rotating counterclockwise? Counterclockwise. Let's see. Sine. Yeah, so it's something like, what would the rotation matrix look like? Cosine. Okay, well we need a theta, so double theta is equal to over n. Double mu x is equal to Okay, let's see if this is right or not. Two and 1, 5.93 and 2.387. Okay, I'm gonna submit everything now. Problem D. Let's test problem C. Okay, it's supposed to be 2. Oh, minimum possible value. Okay. Min. Out 1. That's weird. Okay, we got D. I want to just check B for now. Okay, B is 4. Okay, wait. So this should be 4. Sample input 2. That's also 4. This one should be 3. Okay, and then problem A, we'll just check really quickly. ABC to BCA. AAB to ABA. Okay, let's see problem C. Their bitwise ORs are 5 and 7, whose SOR is 5 and 2. Oh shoot, hold on. And we have to do temp. Yeah. Nope, that's not right. This should be 2. This should be 0. This should also be 0. Okay, so we do this. Okay. Problem E and then F. Problem E is like this, problem F is this. Alright, we have A through D. Let's like check really quickly whether E or F is easier. They seem to be about the same difficulty actually. written on that edge in that path. Okay, there are M balls. Each ball is a certain coordinate. Each ball is a color represented by integer ID between 1 and n. ID of the color of ball is Ci. Okay, X is distinct. Collect all the balls by moving along the line that return to coordinate 0. Oh, okay. And we have to be in a non-descending order. Interesting. Non-descending order. Okay. I mean, we could probably just simulate the process, right? Oh. And you have to return to coordinate 0. Can we do a DP? So because, okay, no matter where we're located on the board, it should be optimal for the last ball of a certain color that we take to be a ball that's either the first one or that's either the first occurrence or the last occurrence. So if we do that, and then we could do a DP, right? Yeah. I feel like that's it. So public int. Okay, so that's the leftmost and rightmost occurrence of a certain color. And then we have to process these colors in increasing order. Okay, and then BP at 0 to nope, I at 0. Okay. So this ends at left, so true. Okay. How do we do this? Okay, so if it ends at right, else we do something else. Okay. So we start at prev. Long dist is going to be, okay, what if we go from the previous to A, and then go from A to B. And then min of this is with itself. So we go from dist from previous to B first, and then we go to B minus A, or ABS. And then from here, we have to go back. It's like 2 times this. this test case. 24. Okay, I'm probably just calculating something incorrectly. Okay, 213 crew. Crew means we end at the... Oh, wait. False crew. False crew. Okay, still 10 though. 213 if we want to end at the left. And it's like 1, 2, 3. 213 false is the same thing. 213 true. 1, 2, 3. 104. So it's like 0, 1, 2, 3, 4. We start over here. False means we want to end at the left. So 1, 2, 3, 4, 5, 6, 7. Okay, that seems legit. 304. So 1. Oh right, hold on. These should be 1 indexed. Yeah. That should only matter for the base case. It's 12. When it's supposed to be 38. -1. How am I getting previous as -1? Equal to 0. Maybe. Still giving 30. Is this correct? compress these colors. That might make it a little bit easier to think about. So if we do this, or ball x dot color. This is how many colors there are. Do something like this. Yeah, that way we don't have to worry about this condition over here. We can just do this. We don't even worry about that. And then this is like M, 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 M. And because this color always exists, we can just do this. Okay. Let's see if this helps or not. Okay, hold on. We're still getting -1. What? That's not compressed properly. Oh wait, I'm dumb. It's N. Still get 30. Is there any other constraint that I didn't realize? Move along at least 1 per second, or then return to coordinate 0. I did account for coordinate 0, right? Yeah. In non-descending order, so increasing order. So when you collect the ball, you have to be at the coordinate of that ball, but you don't have to collect the ball if you're there. Okay. You start at coordinate 0, collect all balls, and then return to coordinate 0. start at the previous L, and then you want to end here, start at the previous R, and you get up here. Is this value still correct? It is. Okay, so what is the smallest color? 5433522234. Oh wait, they can be negative coordinates? Oh, shoot, I didn't realize that. Maybe that's why? Yeah, okay. I did not realize that. Okay, I think in here is covered. It's just the base case that's off. We have to do a absolute value of right plus the absolute value of this. Still 30. How is it still 30? That's really weird. Left then right. Oh wait, no. Oh shoot, I'm dumb. This we should be storing what do we store? I want to store the minimum, like the actual coordinate. Location. Wait, are we sorting? No, it's already sorted by location. Yeah. It's still 30. It's really weird. Like, it's weird how, like, I'm making all these changes and the answer is, like, still giving 30. It just doesn't seem right. Bro, just run. Please. 7, 2. And like 1, 2, 3, 4. BP at 0 and 1 should be absolute value to, oh wait, I have to go to the left. I have to get, if I start from 0, my left coordinate is here, my right coordinate is here, and I have to end up somewhere. And then I have to end a crew. Okay, so we do this. I think we modify this a little bit. So if if we're going to the right, then we do this. Like that. Okay, it makes a little bit more sense. We should probably do, yeah, starting from 0, we go left here to right at here, false. Still 36. I guess it's better than 38. I mean, no, better than 30. I don't know. Let's see. 7 to 8. So then it's like here, here, plus 2. Okay, that seems right. Oh shoot. Is this why? But there isn't a coordinate that's set. Wait a minute. Wait a minute. No, we do something like this. Because look, a coordinate can never be located at -1, or I mean at 0. It's still 12. Okay. Six, 7 to 8, 15 to 12. Are there any cases that are like not correct in here? Okay, well if we're up here, then we started out. These should always be true. Okay. We go from previous to A. Then we go from A to B. Otherwise we can go from previous to B, and then we go from B to A and then back. Yeah. And then if this, A is like nested between here, then we just get this distance. Otherwise we go from previous to B, and then from B to A. Or we could go first to A, and then go from B, and then back to A. And then if this is happening, we just go directly from previous to A. Okay, what's the next color then? Okay, so 3, 4, 6. So minimum is 3, maximum is 6. -3, 3 to 6. It's like 6 plus 3 plus another 3. Equals 2. Yeah. That is really weird. 3, -4, 1. M is equal to this. Okay, this is N. They're sorted by their location. So this should be right. Okay, let's get rid of like middle elements. 2, 2, 3, 3, 3. We can get rid of this and return it to 8. This is all sort this by their locations. So -5 to 5. -4 to 4, -3 to 2, 1 to 4, 2 to 2, 3 to 3, and then 5 to 5 and 6 to 3. Oh my god. Absolute value. At left. Let's see if that's the only reason. God damn it. God damn it. 38. And sample input 1 is debug, if debug. Okay. Got that. See if this works or not. That is really weird. Okay. I'll just look up problem F for now. Problem F, you're given n and then a grid for each value. Okay, so you choose any path from 1 to n. Let's see. N is 1,000. Okay, a palindromic path exists from node A to B if there's an edge such that those endpoints of those edges also have a palindromic path, and like those, and the tag of those are the same. Yeah. Okay, so if it was something like this, 1, 2, 3, this went to A, this went to B, this circled around to A. Path from 1 to 3 is equal to 2 plus the smallest palindromic path from 2 to 3, which is 1. Okay. And then that's like n squared dp, kind of. Let's try this. How many edges are there? There's at most 1,000. Okay. Actually, I should probably do this. Okay. How do we do this? Probably do like most of the southern edges, there are good. So then it's like 4 each. Okay, so 4 into 4. And so, okay, if x is not equal to a, no, if x is not equal to a, or y is not equal to ten, 5, and -1. Let's see. Really? Still wrong answer. It's mostly correct though. That's actually unfortunate. Y and tag, X and tag. Oh, does a palindrome have to be positive length? Well, yeah, it does. Maybe we do like a BFS style instead. That might be possible. Yeah, because the order could potentially be like a little weird. I'm gonna try that. Yeah, I'll just try that. I might have to turn this to a BFS. The way we do that. Okay. A to B plus 2. DP at V next. Like this. -1. This one is different because now we're using DP. Oh, no, not DP. We're using a BFS. Let's try this. Okay, we got F. Got F. And now we just have to figure out why E is wrong. This is tricky. Why is E wrong? That's really weird. So for DP, well, is it true that we always go to endpoints? I'm gonna clean up the debug statements. So we compress these values just because it's easier that way. Change the colors. Yep. Location and color. We don't need to subtract one here. We sort them by their location. I don't think that's necessary, but that's okay. Could these like things be long? Like long. The locations themselves are always integers. That's 12. I'll be kind of annoyed if it's just an overflow. Did it agree? Really? It was just an overflow? Oh my god. That's so dumb. Yeah, the only reason why this was wrong is because of integer overflow. Dang it, dude. Oh, I could have gotten this so much faster if it weren't for that. Whatever. It's fine. Alright. That's my contest. Do I want to go over solutions? I don't know if I want to go over solutions. F is actually a good problem. F is a good problem. That's that's pretty much the only like actually interesting problem. I guess E is like okay as well. Should I go over these? Not. I'll just go over them really quickly. A. If you don't know how to do A, then you don't know how to code. Go learn to code. B, yeah, A is literally just like that, you know. B, what was B? Oh, this, okay. You just like loop in like each of the 4 directions starting from point X, Y, and the moment you hit an obstacle, you like stop counting, in that direction. So yeah, that's what this is for. Did I have an extra semicolon? That's actually hilarious. Whatever. Yeah, so that's B. Pretty straightforward. What is C? Okay, C is, basically, you see that n is only 20. And because n is only 20, you can just, like, loop over every possible, way to split these group of n numbers into like some number of blocks. So the way you can iterate over each mask of n numbers, and every time a bit is set, that's when a current block is like cut off. So pretty much, as you can see, if this bit is set over here, then we create a new block and we add this current block to our overall like value. And then we just take a minimum over all of these values. So that's C. Pretty straightforward, I guess. Just like iterate over every subset and you're fine. D is just math. If you're familiar with like the rotation matrix of like cosine, negative sine, sine, and cosine or something like that, pretty much you just find the midpoint of these two numbers, find the midpoint of the 2 points that are given to you, and then after you find the midpoint, you can take any of one of these points and then you shift everything so that the midpoint is at the origin. And the reason why you do this is so that way you can then, once everything is at the origin, you can rotate it by theta, where theta is 2 pi over n, because it's a regular n-gon. And then after you rotate it, you're going to shift it back by the midpoint. And then that new point is going to give you the answer. So yeah, that's D. What is problem E? Oh right, problem E. Okay, problem E is, I guess it's okay. Basically, you're given a color, well, like you're given a set of balls. Each ball is at a distinct location, and each ball will also have a certain color that isn't necessarily distinct. And so you start at position 0, and your goal is to collect all of these balls in such a way that you travel the minimum distance and you collect balls in non-decreasing order of their color. So you can't take like you can't take a ball of like color 4 before you take a ball of color 3. So it has to be in increasing order, pretty much. And the way you do this is, you notice that in any optimal like path, for all balls with a set with like color C, after you collect all of those balls, you will optimally always end up at either the leftmost position or the rightmost position. So in other words, like for example, in like this sample over here, or I guess, hold on, let me get the actual sample. So for example, in here you have balls. If you look at the balls, all the balls of color 3, you have one located at 3, one located at index 4, one located at, position 6, I guess. These are all positions, not indices. So basically, what I mean is, in any optimal path, you're either going to end up at the, your last ball taken of this type of color is either going to be the one at position 3 or the one at position 6. It's never going to be the one at position 4. And the reason why this is true is, I guess it's kind of intuitive, but if you wanted to go about formally proving this, you could probably just do like a case analysis, where it's like, if your current position before you process any of these balls is like outside of this range, then it's obviously true. And if it's like within each of this range, then because you have to go to one of these because you have to go to both of these extremes at some point, because you have to collect the ball at that point, you might as well just stop there. You know what I mean? So yeah, because then otherwise you would take like a point, like go to the left, and then you go all the way to the right. And then if you were to end at a point that's not the left or the right, then you would have to like travel some extra unnecessary distance. So yeah, once you notice this, you can just do a simple DP, where basically the first parameter is, you're basically solving for each prefix. So you solve for like up to the ith term, and then also you care about, after you process the ith term, whether you end up to the leftmost index or the rightmost index. And so what I ended up doing is, I actually ended up doing the DP by like a colors. So M is the number of colors that there were in this array. and then I just like process them like this because you want to process the colors in increasing order. So yeah, I guess to type it out, it's like dp at like dp at c, and then at like 0, it's going to be answer for processing all balls with color less than or equal to C, and you end up at leftmost position of at the leftmost ball colored C. Yeah. And then DPS C1 is the same thing, except you end up at the rightmost ball. You end up at the rightmost. So yeah, that's pretty much it. I think it's just an okay problem. The casework in here is kind of annoying, but it's fine. Problem F. Okay, problem F. Problem F is actually pretty good, in my opinion. At least for an ABC. So pretty much, you have, what do you have? Wait, what was this problem again? Shoot. Okay, so you have an undirected graph of n vertices and m edges. And each edge has like a label on it, and this label is essentially like a character. So like it has like char, it could be A, like char B, char R, like whatever. It doesn't really matter. There's just 26 different characters that each edge could be labeled with. And the goal is you want to pretty much you want to how do I say this? Shoot, what was I going to say? Yeah, pretty much you want to find a path, like any path, from vertex 1 to vertex n. And what's important is that you can actually repeat like some edges and a range of characters written on the edges of each path. Okay. And then we want to figure out whether this resulting string is a palindrome. So one thing that's really important to know is that, or like one thing that's important to realize is you can just how do I say this? Okay, so I feel like it just might be easier to go over the code first. So in here, I just like read in all of these edges, and I actually group all edges with like the same weight on them in like one group, I guess, over here. And then I do a DP, or like a BFS. And DP at this value means that it basically tells you the minimum length of a palindrome that starts at node A and ends at node B. So in this case, any path that starts and ends at the same node is going to be 0 because you can just not do anything. And if there doesn't exist a palindromic path, then I just label it as infinity. So what is the important thing to realize? Wait, am I reading this problem correctly? Wait, so you can, in a range of characters written on the edges. Wait, does this even work? Hold on. Why do I feel like this doesn't work anymore? Wait, I mean, it passed, it like AC'd, but... Okay, let me just make sure I'm not like being really dumb. 1, 2, 3, 4... Okay, hold on. This was A. This was B. me try something. Wait, no. So 6, and there's 5 edges. Go from 1 to 2 with the label B. 2 to 3, edge C. 3 to 4 with A. 4 to 5 with B. And then 5 to 6 with C. That is so funny. Oh my god. Okay, let's make a string and arrange the characters written on the edges in that path. Let us make a string by choosing a path from vertex 1 to n, possibly with repetitions of the same edge and vertex. That's actually so funny. I misread the problem. And okay, that's actually funny. But like it somehow passed passed all the test cases when it really shouldn't have. Okay, that's fine, whatever. I guess I'll just go over the way that I interpret it. So if you read the problem, basically you choose any path from vertex 1 to n, you rearrange the characters on the edges of a path, and you want to figure out if you can rearrange it to a palindrome, and if you can, you want to find the minimum possible length of a palindrome. So pretty much, I interpret the problem as you pick any path, and then you check if it's a palindrome or not. So, basically, this problem is like, at least I believe my version, the way I interpret it, the problem is like much easier. So, pretty much, the way you do it is, you like do the DP that I mentioned before, where it's like, minimum length of palindrome from A to B, or infinity if one doesn't exist. And so, pretty much, you want to do a BFS from all of the base cases. And so every base case will look like either you start and end on the same node and the length of that palindrome is just 0, or you can loop through every edge and then say, if there's an edge directly connecting node A and node B, you can just say there's a palindrome of length 1 from A to B, because any string of length 1 is also a palindrome by default. And so with that, you can just do a BFS, and then for each character, you want to loop over all edges that are adjacent to node A, and all edges are adjacent to node B that share the same like tag, because you want it to be a palindrome, right? And then you loop over each of these, and then you say, and then you essentially just do a state search. So state in here is dp at x to y, and if you can create a shorter palindromic path from like node A to B that like leads into x and y, then you set the this value, and then you add it into the queue. And so the +2 comes from the fact that you're essentially adding 2 edges with the same edge weight on this palindrome. So what I mean by this is, let's say if your current palindrome looks something like AXA. The reason why I'm adding 2 is because I'm basically adding like a character on the like start of a palindrome and on the end of a palindrome, and these characters are the same. So it would then become something like BAXAB, for example. And so that's where the +2 comes from. And yeah, after I do the BFS, I just check to see what this value is. If it's infinity, then obviously a palindromic path doesn't exist. And this runs in n squared. So yeah, to be completely honest, I'm not really sure if maybe they intended maybe the problem was intended to be interpreted in a way that I like implemented it. Maybe not, because I feel like if they really, because okay, by their method, but like by their interpretation, I guess this should return 5, but mine returns -1, which is correct by my interpretation. So it's really weird. Yeah, I'll look into it. But other than that, that's pretty much how you do, the way I interpret it at least. I'm not immediately sure how you would do it if you could rearrange the characters. But yeah, that's pretty much it. How did I rank overall? Okay, 263rd because of really bad penalty. You know what? That's fine. I'm okay with that. Yeah, but my penalty on E was just really bad for some reason. It just I just had a bunch of bugs, and I also didn't realize that coordinates could be negative, so I had a problem with that as well. But other than that, it didn't go too bad. Yeah. All right. I think that's about it for now. There's Codechef in 20 minutes, so looking forward to that. Not really, but whatever. Yeah. See you then.